from the depths of the earth to the palm of your hand. This is how a smartphone is prepared.
In this video, I'm going to explain to you how smartphones are created, the ones that you are using right now.
Every day, you pick up your smartphone without thinking about what it took to create it. Inside your smartphone lies a complex world of rare metals, engineered materials, and microscopic technology. At the heart of every smartphone sits a powerful processor built from some of the purest silicon on Earth. But the story of your smartphone begins far from circuits, deep underground.
The journey begins in mines like these, where cobalt is extracted for smartphone batteries.
Cobalt is one of the most critical materials inside your smartphone's lithium-ion battery.
These raw cobalt rocks are the starting point for storing the energy your smartphone needs to power every app, every photo, every swipe. Lithium, another essential smartphone metal, is extracted from brine beneath these vast salt flats. As the sun evaporates water, lithium concentrates, becoming the fuel for your smartphone's battery.
Copper, one of the most important metals inside smartphone wiring, comes from open-pit mines like this.
Copper inside your smartphone circuits begins as rock that must be crushed and refined. Smartphones also rely on tiny amounts of gold for connectors that must never corrode.
Nickel is used to strengthen smartphone casings and internal components. Most smartphone bodies begin here, where aluminum ore is extracted before being processed into sleek metal shells.
Even your smartphone's glass begins with silica sand, heated and formed into strong, transparent surfaces.
Materials from around the world travel thousands of miles before they become parts of your smartphone. These rare metals begin an international journey across oceans toward high-tech factories.
Once they arrive, the raw materials are refined into the pure elements your smartphone needs. Lithium is refined into battery-grade material, ready to be turned into smartphone power cells. Cobalt is transformed from raw rock into the essential powder that stores energy inside your smartphone. Gold becomes ultra-thin wiring inside your smartphone, where reliability is everything. Once refined, these materials move toward the next stage, the creation of your smartphone's high-tech components. Purified silicon is transformed into flawless ingots, the foundation of every smartphone chip ever made.
These ingots are sliced into wafers thinner than a coin, ready to become smartphone processors.
Photolithography etches billions of microscopic pathways onto each wafer, turning raw silicon into smartphone intelligence. These tiny lines, thousands of times thinner than a human hair, carry the electrical signals that power your smartphone.
One silicon wafer becomes hundreds of individual smartphone chips, ready for packaging.
Chip packaging shields each smartphone processor and prepares it for life inside your device. Every smartphone chip is tested for speed, heat, and reliability long before it reaches your phone. Battery components made from lithium and cobalt are layered to store enormous energy inside a tiny smartphone battery. Electrolyte fluid enables the chemical reactions that let your smartphone charge again and again. Each smartphone battery undergoes extreme testing to ensure it can survive years of use. Smartphone displays begin as molten silica, stretched into glass so strong it can survive everyday life. Ion treatment makes smartphone glass resistant to scratches and impacts.
Organic LED layers create the bright, colorful images you see on your smartphone screen.
Smartphone camera sensors are engineered at microscopic scales to capture light with incredible precision.
Multiple tiny lenses work together inside your smartphone to capture sharp images and videos. Every smartphone relies on a motherboard packed with thousands of miniature components. Robotic systems install each smartphone chip with flawless accuracy. But aluminum frames are machined with extreme precision to create your smartphone's slim, rigid body. Anodizing protects the smartphone frame and gives it the color you choose in the store. Now the components come together, transforming raw materials into a working smartphone. Software is installed and tested, bringing intelligence to the smartphone's hardware. Touchscreens are calibrated with robotic precision to ensure every tap and swipe feels perfect. Only then are smartphones boxed, sealed, and prepared for their journey around the world. Once complete, every smartphone begins a global journey, traveling thousands of miles towards stores around the world. Millions of smartphones cross oceans on vessels like these, forming one of the largest tech supply chains on Earth. Distribution centers sort each smartphone with incredible precision, sending them to cities, stores, and consumers worldwide.
Finally, smartphones reach retail shelves, where millions of people compare screens, cameras, and colors.
Unboxing feels effortless, but behind that moment is a global system of engineering, mining, and manufacturing.
The moment your smartphone powers on, billions of tiny components come alive in perfect harmony. From morning until night, your smartphone becomes a map, a camera, a library, and a connection to the world.
Your smartphone camera, powered by microscopic sensors, preserves the moments that matter most.
Each tap and swipe sends signals across networks that circle the planet. Every smartphone relies on vast cloud servers to store messages, photos, contracts, and memories. Smartphone sensors interpret light, depth, and movement to unlock your device with remarkable accuracy. Inside the smartphone, billions of transistors fire every second, powering apps, photos, videos, and AI features.
Lithium cells inside your smartphone constantly store and release energy to keep up with your day.
Millions of unused smartphones sit forgotten in drawers, tiny time capsules of old technology.
Smartphone waste is one of the fastest-growing environmental challenges in the world.
Recycling facilities recover valuable metals from smartphones that would otherwise be lost. Even the gold and copper inside old smartphones can be purified and used again. Recycling rare earth metals is difficult but essential for reducing pressure on global mining. Refurbishing extends the life of smartphones, giving them a second chance in someone else's hands. Recycled smartphone materials re-enter the global supply chain, completing the cycle. And once again, a smartphone reaches someone new, ready to become part of their daily life.
Your smartphone connects you to people, ideas, creativity, and information in ways previous generations could only imagine.
Inside every smartphone is a global journey of metal, glass, technology, and human ingenuity.